On number 2, we are to find the domain of the function f and use limits to describe the behavior of f at the values of x not in the domain. In this particular function, we have one non-canceling factor in the denominator, which means we're going to have one exclusion from the domain, and that exclusion is that x cannot be 1. So our domain is negative infinity to 1 union 1 to infinity. Then we are to describe what happens on either side of 1 when we hit our vertical asymptote, which is what we're going to end up having here. This will create a vertical asymptote at x equals 1. So we want to look at the limit as x approaches 1 from the left of our function, and then we want to look at the limit as x approaches 1 from the right for our function. And remember, by definition, a vertical asymptote, the function has to either zoom straight up or straight down when we get there. And to figure that out, we're going to pick a number to the left of 1, which would be 0.9. And if I plug 0.9 into this function, we would have the negative 3 on the top, so we'll put our negative on the top, and the denominator would be negative because you would have 0.9 minus 1, which is negative. So then a negative divided by a negative implies that our result would be positive, and since we know it heads to infinity, we put infinity. We'll do the same thing now, but from the right we're going to look at maybe 1.1. Well, the top stays negative because it doesn't depend on x, but in the bottom, if I plug in 1.1, I would get a positive value. So now I have a negative divided by a positive, which implies that my result will be negative. So that means that on the right side, this function should go to negative infinity. And we're done with number 2. Now let's look at number 4. Number 4 has a little more going on because we have a factorable denominator, so we need to take care of that first. So we'll keep the top, rewrite the bottom as x plus 1 times x minus 1 because we see the difference of two squares there. So now we have two exclusions. So when we set up our domain, working from the left, we would have negative infinity to our first unallowed value or disallowed value would be negative 1 for that first 0, union negative 1 to 1, which is our second disallowed value, and then it picks back up on the other side of 1 and goes to infinity. So now we have a three-piece domain. Tells us that when if we were to graph this function, we would have 3 pieces. But we also are going to have 4 limits to describe on this one because we have a left and a right at each of the 2 vertical asymptotes. So the limit as x approaches negative 1 from the left. We'll do the limit as x approaches negative 1 from the right of f of x. We will then look at the limit as x approaches 1 from the left of f of x, and the limit as x approaches 1 from the right of f of x. So let's start back over here with negative 1 from the left. Well, if we're going to substitute negative 1, or approach negative 1 from the left, negative 1.1 would be to the left of negative 1, and again, our numerator in this one is going to stay positive because it's a constant, but I have 2 factors whose signs I have to consider, and if I substitute negative 1.1 into x plus 1, I would get a negative. And then if I plug negative 1.1 into x minus 1, I would also have a negative, so these 2 negatives would cancel and give me positive infinity. If I plugged a number that is to the right of negative 1, I might use something like negative 0.9, but again the top would remain positive because it doesn't depend on x, and then in the bottom I have to look at both factors, and negative 0.9 would make the first factor in the bottom positive, but it would make the second one negative, so I have one negative makes the quotient negative. So we have negative infinity there. And then for positive 1, as we approach it from the left, we would look at positive 0.9. Again, the 2 on the top is going to give me a positive in the numerator. Then we're going to look at each factor separately in the bottom. If I put in positive 0.9 with plus 1, obviously that's positive. If I put positive 0.9 in with x minus 1, that's negative. So this one would be negative infinity. And then the limit approaching from the right of 1, we could use 1.1. Again, the top stays positive because it's unaffected by x. And then in the bottom, positive 1.1 plus 1 is still positive. Positive 1.1 minus 1 is positive, so this one is positive infinity. And that's all I had to do for number 4. Let's look at number 6, where we are to describe how we would transform the parent graph 1 over x into this graph. Well, one thing that might help you think about the transformations is to rewrite it by pulling off the numerator as a multiplier, and that will help you see that that's really our a. And also remember that inside versus outside, as we discussed it in chapter 1 for function transformations, the inside is wherever x is in the parent, and since x is in the bottom of the parent, that makes the bottom of this function the inside. So when we start accounting for things, if I account for that plus 5 first because it's inside the bottom, that means it's going to be backwards. So it's going to take our parent graph to the left 5, and with a negative 2 multiplier, we're going to have a vertical flip and stretch by 2 in our graph. So let's grab a pair of axes here to graph with. And give ourselves plenty of room to slide that vertical to the left. We'll pull it out this way. So let's start with, like we have on previous examples we've done, let's start with the parent in one color, and we'll do it in yellow. The 1 over x parent will be in yellow. And remember, you start from 1, 1, and you go up and hug the vertical asymptote, and you come back down and make a sweeping smooth curve and hug the horizontal asymptote. Then you go left 1 and down 1 to negative 1, negative 1, and do the same thing. We don't want a line there that looks like a line. We really want a rounded curve here. And the closer you are to those corners, sometimes the harder it is to make it look like a nice smooth curve. But that's roughly what the parent's going to look like. Our graph we're given to do is going to be this graph moved to the left 5, flipped and stretched. So we're going to move first our vertical asymptote, which will be at negative 5, which will be right here. So we'll sketch in a vertical asymptote, make it reach from top to bottom in your graph. So there's my kind of sloppy vertical asymptote. And then now the center of this graph has moved to the point negative 5, 0. But now we're going to put the pieces of the graph together by thinking about the fact that if we graph the parent from our center of where our two asymptotes, vertical and horizontal, intersect, we would go to the right one, up 1, left 1, down 1. Now we're going to go to the right one, and instead of going up 1, we're going to go down 2 because this is a vertical stretch and a flip. So that would put me here for this point. That's my kind of anchor point, and we go out and down. And then for the other side, where we would normally go to the left 1 and down 1, now we're going to go to the left 1 and up 2, which would put me here. And again, you want a nice smooth curve that hugs your asymptotes. So you sweep up the vertical asymptote and sweep around that corner smoothly as you can, and that is our sketch. For number 10, same set of directions as for number 6. We have to talk about transformations and then sketch it. But we've got more going on here. Anytime you have one where the degrees match and you're trying to use the function transformations approach, you want to rewrite this function so that it looks sort of like, we'll call it vertex form, and so that we can see the A, the H, and the K. And to do that, we're going to divide. And you could use linear, I'm sorry, excuse me, you could use synthetic or long division. I'm going to use synthetic here because the president told me to. So remember though, when you list your coefficients here, you start with the leading coefficient, which here that would be -3, and then 4, because you want to go in descending powers of x. Bring your coefficient, your leading coefficient down, multiply up, and then add. So then we would translate this into, since that we divided a linear into a linear, this is a degree 0, which is a constant, so that's going to be our k. And then we had a remainder of 11, so we put -11 over what we were dividing by, which was x minus 5. And there's my transformed version of this function. So this is going to be, let's list our transformations down here in the corner out of the way. So because of the -3, we know we're going to go down 3 from the parent. And the -11 is a vertical flip and stretch by 11. And then the -5 inside, because it's inside, is backwards. It's going to take us right 5. So let's see if we can't get a decent picture of this going over here in this space. So we will start again by getting our axes set up. And then we'll graph the parent in yellow, just to be consistent. And remember, the parent graph goes through the point 1, 1, and then sweeps up and out in both directions. And then it goes through the point -1, -1, and then sweeps down to down the vertical. Ooh, that's terrible. Let me try that again. Late and I'm tired, so bear with me. And then it would sweep around in a nice rounded corner and out the horizontal asymptote. So there's the parent for us to work from. Alright, now we want to get our transformed graph on here. Since we got so much blue going on here, I'll switch to green to help it show a little better. So we want to go down 3 and right 5. I would do that part first because that sets the location of your asymptotes. So let's go down 3 means we're going to have a horizontal asymptote at -3, which will be right across here. And then we would have a vertical at 5. Which would be here. And then where normally we would go to the right one and up one from our intersection to plot the anchor point, because we have a flip by 11, or I'm sorry, a vertical flip and a stretch by 11, we would go to the right one and down 11, and since we don't have room to do that, you know that we would be off the screen, so it's going to come up from down low and sweep out like that in that corner. Excuse me. And then we're going to go to the left one, and where we would normally go down 1, we're going to go up 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That puts me, let me double count that one, which will put me right there. It's almost on top of my arrow in case you can't see it. Alright, so I'm going to come from there and go up, which is going to make me have to sweep out like this to make that a nice smooth curve. So when you have points that are pulled away from that intersection, your corners are going to be much more rounded in your turns. And that's a sketch for number 10.